Well, there's Peter. I better do something rather than just sit here. I could chat too, but what's happening? Don't know if anyone's particularly interested in this or anything. But anyway, probably if I published a probably if I made sort of a thing of actually promoting it, people might be more interested. Not good with that. There's two people there now. So, anyway, there we go. I've been messing with a few things. I've sort of been messing with this. I'm still not happy with it, to be honest, for a couple of reasons. It's not a very simple job to actually make this shape. This is the top panel of Bill's hardness tester. This is what I've got, but it's not real uniform or smooth. I don't like it much because I did it in separate panels. Don't be right. Don't put yourself down, TMB. Good to see you. It's TMB watching. It's cool. But look, this is what I'm doing. A bit of this, but it's not right. If you look at the reflection on it, see there's a hollow spot there. See that? And there's a dent there. Apart from that, this is sort of all okay, but the same dents there. Anyway, that's where I'm at with that. I'm not sure I'm going to do. There's 5 people there now. Hey guys, I'm not sure I'm going to do a lot with this tonight. Looking at it, and I've sort of made a little bit of progress and a bit of a play with it, and I've got some shapes. These are all, if we're having a look at this, they're actually, some of them are lofts and some of them are fills, but most are fill function, which basically fills up the shell, and when all the insides are enclosed in, you've got a solid sort of automatically. If we change this to section view, we call that a section plane. If we look at this, we've got a solid with wood grain even all the way. That's the last one. If I press as the last join up, gives you some idea what we had before. Parts with this line in the middle. Not happy with this. Not happy with the front. There's a lot to be said for organically doing this with a file and a bit of sandpaper on a block of wood. That's what'll happen. I don't know. Maybe that's an option to do that. This will need at some point a unsuppress that, and that'll show it all as one piece. But looking at this, at some point it needs basically a cutout in here. looks or how it's supposed to look. If we press the P button to turn the planes on, and you sketch. And the P button to turn that off, we can put basically a sketch on here. Looking at the back of this. I don't know where, but there's a cutout, something like this. Not happy with this, really. It's a bit of a tricky thing, and that's probably why I haven't done a lot to it. These are guessing measurements. Very much so. But it's okay to put measurements that are a guess, or some sort of guess in there. That or something like that. We can probably sort of measurements that. I've had one of those weekends. So that gives us something that looks a bit like that for the indicator. Don't know about that. Not fierce at all. Anyway, that's how that is. Not happy with that. We'll have a bit more of a play with it. Who else is around? We got 5 and then we're back down to 3. So we've got Peter and we've got TMBs in the background there somewhere probably. No idea who else is here, but I'm going to have a play with this. We're back up to 4. Anyway, going to have a play with this at some point. Probably by next week I'll have some actual answers and be able to show you how I did it. But there's some fun job. There's some funny shapes in this, to be honest. And I need to sit down with the manual for a bit and have a look and see what it actually had and how it looks and how it works and all that stuff. So there we go. Peter's almost always there. So what else have I done this week? We'll have a look at some other stuff. Because road. It's Tuesday again. Don't feel like I've achieved much. I had every intention of Mark's probably still up at the Petrie at the steam shed. I had every intention of going up. Life's too short, and I've got some news which I'll share tomorrow night, which gives me a little bit more time on things, but sort of, almost. but I'm not sure how effective it'll be. At that, there's still lots to do. Let's have a look at these. This is a job for Mark, I guess, if he doesn't actually find a real one. I really hope he does. There's two ways that this could be done as a really complicated, a really simple job. We'll wait till this loads. Here we go. This for a T3 Fowler road roller. If you don't know what that is, you haven't been following this channel for long. It's different to the one on the D3, much smaller machine, I guess. Physically, not so much, but weight-wise and capacity and stuff, it is quite a bit smaller. So this has got half-inch. Basically, it's a half-inch valve, they call it, rather than the 3/4, which is what the D3 has on it, which is my roller. And it's quite a bit different. Otherwise, we'd just be copying the ones that are on the roller. There's also differences in the way they're set up. If you have a look at this, it actually sits on the boiler below the center line. If you have a look at that, it sits vertical there and below the center line of the boiler. And that's the thing that's a bit unique from what it seems to the T3 roller. The Fowler Tiger, which is the same engine in traction engine form, has two at the top, the same as the D3. But the T3, same as the DNA or the D series anyway. The T3 has one below the center line, which means you're pumping into water, which is probably not a bad thing, rather than pumping in the steam cavity. There are reasons probably it got done like that, and I would expect it to probably be a more sensible way to do it. But anyway, now there's two different clacks. I've got a drawing from 1930, which is much more modern. It was 4 years more modern than Mark's roller or my roller, and that shows a bit of a design. A revision in the design, which is quite a good design revision, to be honest. Look at this. In that it's got an isolating valve in here, which is a good thing. It means double isolation on the I think it's the water pump side. So you can actually isolate the boiler here and turn the water pump off. I'm not sure why you would want to do that. But it also means that you can do the seats in this and the seats in the pump without dropping the engine out of steam, which I guess is sort of a benefit, but I'm not sure under which circumstances you would ever do that unless you had parts to put them straight in. Looking at this, I think Peter's probably already seen most of this because we had a look at it on Discord. This is what it looks like. It's got a pipe out the bottom which feeds in here. Look at this curve, so it feeds in here with a drain, and it's got basically two non-return valves in here. A conical clap valve, or spherical, I guess, nearly spherical valves. One here and one here. And that pushes, once the water's past them, it pushes through here, past this isolation valve. There should be a bung or a bolt or a screw in here and one in here. And this one I guess they're both sort of test cocks, but this would be a very useful thing because if you get something stuck in it, you can actually pull it apart and clean it, or sort of isolate it and at least pump some water out here and get rid of the crap in it. Anyway, that's a bit of a job, and that's what I've been messing around with a bit too. I spent a little bit of time on this on Sunday and a little bit of time Saturday night, so I haven't put a lot of effort into it. It looks like quite a complicated drawing, but it's not. I'll probably put 4 or 5 hours into it, I guess, all up. If we look at that and break it down, probably the best way to do this is you look like you're ready for bed. So what we've got is two valve seats there with limited lift. This cab here is supposed to have a spigot sticking down to stop this one lifting as well. And of course there's a tapered plug cock in here in the back. Now, as far as I know, and I can't find a drawing for that, but the previous version of this was exactly the same, except instead of this coming out the side here and past a clack valve, I believe it straight out the back here and into this. So to make the other version, probably all we've got to do is remove all this and push that across there so it fits onto that spigot there. And that'll give us a basic clack valve, which is a much simpler thing to cast and to machine. Quite a simpler thing to cast and machine. So this in itself is quite complicated. There's a few parts. If we have a look here, I'll set that up sort of on the right. I'll have a look at it here. So there's a basic flange that goes on the pipe. And this side, because it's a blind hole, has a stud in it. And then there's a bolt in this side, which is common fowler practice. And then there's a brass plug here for a drain. This sticks out a bit out past there, so that's not really suitable for a casting plane. If we cast it, let's have a look here. The other drawing. Why that is, I think I'm back. There I am. Don't know why it's done it like that. There we go. Let's put my little talking head back here. We'll live with that for a bit. Sorry about that, guys. I am back. Anyway, without these holes in it, all right, it's got a core in here. We'll have a look at that. Cover blocks up all that. If we close this off, that's sort of what the core is going to look like, which is a fun thing, really. Without the threads on it, of course, and we have to do something about this. So probably a secondary or a secondary part to the core stuck together, and probably nude out this hole because that's fairly easily drilled. But basically the core's this shape gives us sort of the idea of it, and probably won't have, unless it needs it for support, it probably won't have this thread on here, and the spigot sticking out anyway. That's just some can be drilled when it's machined, and this thread here will probably just be undersized, so that so I've done that by have a look at this. What's that? I've done that basically drawing a box around it and then removing all the parts off level with the flanges, so that we end up with two pieces. Give you some idea how that was done. Well, it's just a box, and we've cut back to just removing pieces from the outside until all of a sudden you've got an extra part. And then if you close the extra part off, you've got a core. So that's probably a matter of making a box or a split box or basically a cube for the core, and then removing this piece here from the box when it's in position in the right spot, and that'll give us basically a core, a mold for the core, so that we can make this in sand that does the job. So I think if we cast it this way up, what we've got is some problems, right? One is that this stupid tapered flange, right? We've got this flange on here and this flange on here. Now they've both got to come out through the mold, and they point in opposite directions. So that makes for interesting, for some very interesting molding. I don't know if anyone's thought about that, but actually having this to come out through here and this to come out through here, and because we've got this tapered flange on here, I've turned that over again, sorry guys. If we put a parting line through here about there somewhere, what you find is that you've got sand caught behind here and you've got sand caught behind here. If you try, so if you split it in half and do it in 3 boxes or 4 boxes, so that out this way and half the pattern out that way, it's not an easy way to do it, to be honest. Not a simple thing, even a little bit. So this particular version, I don't know how they cast it in the factory. I don't know whether it's shell cast or whether they actually had an outside, like an outside core box for the shell in 2 or 3 pieces that went in a bigger mold, and they used that to pour into, which is probably the simple way to do it. Or whether realistically making it, you can make it in several pieces and then silver solder or silver braze it up, or braze weld it up. but that's not really the answer either from experience. So thinking that through. Thinking that through. It's a bit sort of bit sketchy. Not an easy thing to cast, even a little bit. They might have been shell cast. More likely it was cast this way up. If we look at it, probably cast something like this way up. With a parting line here and a parting line here. So basically this is molded through here somehow. So half the sand's in here, like down to here and up to here, and half the sand is in the top. And then there's this stupid flange, which doesn't make the job any easier. I'm just thinking out loud there, but I guess the ideal way to do it is that way up, because then they've all got draft. There we go. That's how you do it. If we cast it this way up, how do we do this? How do I? There we go. That doesn't really fix it. It does. We can sort of change it like that. There we go. So use the N key. Shell casting is when you have basically an outer, either in metal or in a disposable shell, and the metal's actually poured into the shell, and the shell's either removed or it's I guess it's a simple form of die casting. But that's how we pour that. There we go. Look at this go. So what we've got, I think, pretty much, sort of, is if we use this line here through the center, through the center there, and put half the core box in there. I don't think it'll work to pour maybe you need to do like an offset mold and actually have fill this up with sand. It's pour the lot and then scoop it or pack a big box full of sand with this inside it, sit it up on some blocks or something, and pack from this side, take the blocks out, and then remove this down to the halfway mark through here and up and through here, and then chalk that out or put some mold releases, some slip on it, and then put another box on top of that and cast the top. So that's one way of doing it. I think that's how I would do it, just looking at that. But It's a fancy pattern, to be honest. These patterns, of course, are easy. Part B, that's easy. It's basically in the flat. It's basic with a core in it. And all the core is not as simple as you might think, actually, if we look at it. But that bottom half has some fancy cutouts in it as well. So it's really it's either a two-part core or it's machined afterwards, or you do it somehow with a one-piece core with a reinforcing rod in it and try and make that work. It's very difficult to support the middle because this is offset, so whether you leave this in here and leave a core imprint, like a core print for that, so that when you put this in, it sits on that point there and that point there and that point out there, and it sits in nicely. But there you go. This is not a particularly simple way to actually make a casting, and not a very simple thing like most castings. It's not a simple thing. Most proper steam castings are not as simple as you think they might be. But if you can cut some costs and do it this way, it's a really good thing, because I think Mark got there is a pump casting, which is a very similar thing, being made, and I believe that the wooden pattern for that was in the thousands of dollars to get that done. So this is probably we can get out of it for a lot less than that, I think. Anyway, so that's something I've been working on. If we go back to the assembly, if we look at this, these are quite simple parts. Some fun machining, some really good design ideas in it, to be honest. For a ventilation valve, it's got a lock-up tab with a bolt on it. And take that out if you want to shut it or open it, but I sort of think, well, maybe the lockout tab is just to make sure that it is locked shut for safety reasons. If you're actually you're gonna use that. There's also, if you have a look at this, there's a bolt goes in here, which is easing bolt, it's called, which is interesting. It's a 3/8 bolt, sits up through there, and that puts a little bit of pressure. And the gland holds this down. It's just a standard gland. It holds that down in the casting. If we do this with another section view, which is a very useful tool, actually. If we section that like that, this bolt What's happened there? Interesting. There we go. This bolt holds this up a little bit against the packing so that this taper doesn't lock together, and stops makes it so that you can actually open and close the thing. So there's some fun machining jobs in here, as far as machining this taper in here and then machining the plug. There's you see the matching plug. To machine that to match the tapers looks like fun. The gland's pretty straightforward. It's not a big deal. But yeah. You can see the gland there. So that's sort of what I've been working on. Whether this will actually come to fruition, there's two clacks on this roller and they're both different. A Tiger and another T3 or two other T3s that I've actually seen pictures of. They have a high clack on both sides, as does my DNA, and the DN1 and the DN and the D series rollers all have two clacks on them, which are both above the center of the boiler. So that's really nice because it's the same casting on both sides, so you're only going to make one pattern. But this is actually a little bit unusual with this, with the isolation and everything. So just a matter of spending some time and working out how we're actually going to put the parting lines in it. The best way is just to print out a miniature in quarter size, something like that, and have a good look at it and start drawing parting lines on it, and ask a few foundry people what you think, and probably we can make that work. What would be nice, I think, is to click that face. If we want to turn this round, right, if we want to turn that level with that, so we're looking at it straight on, we can click that face and click N. It's a little, see, and that brings that up level with that. Do the same here. If you want to look at that, just click N, or this one. So this is a fun little feature. If we were to pour it this way up, it means that all those flanges will release nicely. The bottom half here of the core box will all fits really nicely and fits together. Now this bend that goes up here to this piece not so easy, because if we cast this with a core in it, will require some thought. But that's one of the jobs I've been working on. As far as that goes. Anyway, we've still got 20 minutes. So let's have a bit of a look at something a bit sort of on. Just looking at CAD drawings that I've done is a bit boring. Anyway, so we've got 4 people watching this, which is a bit strange, and I'm sorry, guys. I'm sort of not really got a lot to show you tonight. We'll have a look at this. Right, start on an automaton. An automaton donation box, which is kind of, the idea is to have something that actually sits on top of an old plume oil box. I've got a lady who's making replicas of those, or fakes, I guess, replicas, which is really awesome because most of the original ones are worn out or rusted out or rotten out or whatever. So I've got one of those, and I wanted to set this up on top of one of those. Probably with a double lid. Give you some idea. This is how we can set that up above the. We can fasten those together, and then we just offset it. I'm guessing this is a metric drawing, I think. Wrong way, so we'll go -50. Looks like it probably is an actual metric drawing. So what I had intended is to do something with some cotton reels in between, and some gears and things that you can actually see, some wooden cogs and pulleys and things in here, with basically a block of wood in here with a hole in it, and a shaft or a broom handle that goes all the way through, or a piece of rod with a handle on this end, so that you wind that, and this lathe works, and the little guy pumps up and down, and whatever's over here, someone shoveling coal into a steam engine or something, or throwing bits of firewood or leftover bits, or maybe have this guy making handrail banisters and things and having a big pile of them, and then having someone poking them into the firebox of a portable steam engine. With a guy opening and shutting the door and throwing in the banister and maybe even have the steam engine running. I don't know. That's the thought process behind that. Because I've got nothing else to do, and it sounded like a really good idea. But if we made this basically to be closed or enclosed on two sides, and then a glass case on the front, and then have this basically some big course, like proper toy cogs in here, in timber, that you can actually see that working as well. You can get down in there and you can see all these parts, and how it actually works. It's pretty cool. And have a crank handle, and then whether we just have a donation slot to put coins in so they drop through, or so that it picks them up and moves them along to the other end and drops them in the box or something like that. So it doesn't sound ambitious at all when we look at it, does it? And that looks like a really good sort of a thing. And I think that would be a very cool project and something that would get a lot of attention. And if you have something that sort of moves the coins along, whether it's like some sort of a conveyor that moves them along, if you drop them in this end in a slot, like in a brass slot, and then have like a something to pick them up and move them along here. I'm still thinking about this, and have them drop down in this end so that you can see them go through. So that's sort of the thoughts, and I'd like to do like this all in laser cut wood, and then or in wood, and probably sizing and painting and stuff, and like have plume oil box with the nice ends, and then have donations on a sign here on a bit of an angle, like it's just sort of slapped on the front. And try and make something like that work. That's a fair bit of work. And at some point this needs to be done, but if I can get all these bits drawn up so that it looks cool and looks like it's going to work, then we can get basically a trip to CNC or a laser cutter and get them all cut out of 3mm ply, something like that, or acrylic, or whatever you want to do. Probably just plywood. We start gluing them and sticking together and staining them up and making everything a little bit contrasty and nice. And a couple of woodworkers, I think, that might give me a bit of a hand with this. But that sounds like a really cool idea. We'd probably have like in this, put a doorway there, but probably have like a portable steam engine backed in here, with a guy picking up a stack of like and throwing them in here, probably, and then some other guy just treadling this, making them and in the pile here. So that's the thought. It's all fairly basic animatronics, or basic automaton, I think. This guy, all he's really got to do is his head move up and down, and he probably put a wire to move his head while he's watching. Might not be much more complicated than that. And this guy has basically got to have his feet standing in the floor and have his body pivot with a piece of wood in his hand. It probably doesn't need to be much more complicated than that. So I have this, basically this set up either on a camera or on a crank to up and down, or to move his foot up and down, and then sit this on a, have this one sort of on a crank, probably with a lever or something like that. But tea and biscuits, you're really right with that. It's a subject that sort of interests me a lot. If someone wants to take this on and actually give me a hand with it, that'd be fantastic. But that's what I'm thinking, and I really that's what I'd like to do. Have something that's sort of a little bit secure and easy to move about, and a little bit less fragile than it could be. And yeah, and the sky's the limit with the thing. But I'd just like something that with some gears and make some big exposed, like proper cogs that turn, so that you can actually see what it's doing. And probably, and you could have a system of spoons on a crank that come up underneath a coin when it's sitting there, and move it along and drop it on another, or something like that. Might be really cool. Don't know. But I believe that putting the time and effort into this it's going to pay off a little bit. So that's pretty cool. Anyway, they're the projects I've been working on. Give me some thought on the design process for that and why I'm going there with that. This hasn't been really a very instructive video as far as actually making bits. And I think that's okay every now and again. So that's sort of what I'm working on and the things I've been doing. Anyway, I might call it. It's going to be an early one tonight. Appreciate anyone who's tuned in and watched this. I really do. That's awesome. It's been a bit of a, yeah, I sort of was in the workshop till about 5 or 6 o'clock and making some parts, and I sat down about 6 o'clock, and I've had a bit of a play with a couple of things and sort of got this up and running, but that's where we're at. Anyway, next week we might actually do some actual making of something, and step by step go through something. Think of something that needs to be made. But until then, it's all happening. So more soon, and I'm going to call this. So appreciate it. Did I cat up all the sheep we got lasered? Yes, I did. Do we want to look at that quick? There was a lot of bits. Have a look. Some complicated, some not so complicated. Yes, it's all been drawn up and CAD. There's a trap there in that the laser cutter works in millimeters and all my drawings work in inches. So I actually got them quoted in, 15 by 30 inches, 15 by 30 millimeters rather than 15 by. There was a video last a quick, like 7-minute look around video I put up last night, which is all that exciting, but it gives some idea of all the bits and how they look. And a lot of them are quite simple. Those plates. This is an interesting little job. This is a illuminated sign, or basically it's a mask for illuminated sign, a railway. I don't know, a platform sign or something. Signal box sign, more likely, which I did in a video. This is interesting in that we can, the font that's used is a set aspect or a fixed aspect ratio. Which is interesting, because if you wanted to fit a plate properly, we'll have a look here. We might just mess with that. I've got nowhere I really need to be. We'll start a new part studio here. Say we've got a plate that's, let's sketch this up. We click there for the front, or we can click here and for the front plane, which is where we want the sketch. If we go for a center point rectangle, that makes it very easy. And so we make a plate that's 200 wide by 75 high. Let's put that in there and extrude that out. Make it 75 millimeters. Let's try with now. Right. Now, if we want to cut this out, laser cut with a basically something from a font, make a design. If you want to make it something pretty, there are the better programs for that. But this will, at a pinch, do it quite nicely. There's vector programs that will give you a much better result for artwork and stuff like that, and a better way to logos and things like that. But if we sketch on this plane, that automatically sets the size of the plane, a sketch to that plane. If you want to put a border on it, we can use this button, which is the use button, and we can put, see, we can just select that and it'll put it in our sketch. Not particularly useful in this instance, but it's something to think about. Use button's pretty helpful. But we've got this text button here. We drag out a box, the same as any other art program. And we want to put some text in here. I don't know what's a good thing. STEAM. Let's make it capital. STEAM. Right, and this is Balthazar, which is quite a complicated little thing. Not a bad font, but not particularly user-friendly sort of a font either. So we can use the dimensions. We can set this up and align this with that. And the center line. and we can align this dot too with this end line. And so forth. And we can adjust the width of it. So because this is a fixed aspect, we can adjust this like this. Well, it's 144. Let's say we'd like that text to be 160 wide. I'll put that in 160 millimeters. Now that's made it a little bit wider this way because because it's a fixed aspect ratio. If we extrude that, right, this might work fine for you, but basically that works. But if we'd like to change it a bit, the best thing we can do is make these parts new. And we've got 5 separate letters. If we turn this around here on the left side and we select these, right, if we select them that way up, that selects all the letters, right? The A-hole's the problem. That's exactly right. If we select from this side down, so from left to right, like so, you only select the features that are completely within that, right? For example, that's the sketch. If we select like this, that's the whole. If, however, we select the other way around, we select everything. Stop that selection. If we select the other way around from right to left, right, that selects all of those, not just the sketch. Right. Now what we can do, if we look at the front of that, we've got those selected. We can use this here, which is the, here it is, where is it? Here. Transform. Right. And there's all sorts of things we can do, but one of them is scale. If we untick the scale uniformly, and that's the Z scale here. It's not though, because it's changed. We've got to put a mate connector in too. So if we want to scale it, we'll put point a mate connector. We'll scale it from the center here, and that'll change that. Right. So what we've done is given us a scale there. It's 1.6 times high. If you want to change it down to there like that, that might look really good. We can do that. See? And then we can remove these, subtract one from the other using the Boolean tool. This doesn't stick through the board though, so we're going to change that first. So it's just flush on front because we put that sketch right here. Click the symmetric button. That should put it back through and make the plane exactly halfway across. Right, and we can use the Boolean function to remove one from the other. Use tools, that one, that one, that one, that one, and that one, and our targets. In the real world, of course, this wouldn't work because you've got a loose piece for the center there. But that's how you can make a pretty cool laser cut or 3D print sign, whatever, like that. So that's one of the things in the laser cutting box that needs a little bit of nutting out. That's how you do that. It's not a big job to do it, but that's what happens, and the cut looks really good. It's a nice job. There was some sheet metal folded up parts, and there were some parts that were that basically just plate, the rest of them. So they've all been catted up, and the files are all there in case anyone ever wants any of them. But at this point, yeah, I'm glad to have them sitting in the back of the van and ready to go. So that's how that is. Anyway, thanks, guys. I'm going to call it for sure this time. We're 20 minutes down. Thanks. Appreciate you tuning in. Be kind to each other, all that sort of stuff. And more soon. What sort of burr is on the cut plates? Tea and biscuits? We'll have a look at that tomorrow night. I've got some bits and we'll have a bit of a look at the laser cut. But there isn't one, to be honest, is the short answer. They're pretty nice. I'll have some bits on live stream tomorrow night and we'll have a look at all those bits and give you some sort of an idea. They're pretty good. Like, excellent. And these pieces, there's nothing on them at all. Very clean. There's not even any burnout where they've moved from one point to another, like you get with a plasma, where they're just clean. Anyway, I'm out. We'll catch